Now we're going to go ahead and solve these problems using our sine ratio. So our first problem says, in right triangle ABC, if sine of A equals 2 over 5, then calculate the inverse sine of 2 over 5 to determine the measure of A. So in my calculator, I'm just going to do the inverse sine. If you remember from the previous video, to get the inverse sine, what we need to do is we need to just hit second sine, and then we'll just do 2 divided by 5. You can do 2 over 5 if your calculator allows, but 2 divided by 5 the same thing. So here we're going to get the angle is 23.6 degrees. So I'm going to go ahead and round that to the nearest tenth. The next problem says determine the ratio for sine of B and then use inverse sine of sine B to calculate the measure of the angle of sine of B. So the ratio for sine of B is going to equal opposite. Well, opposite of angle B is 11 over the hypotenuse length, which is 25. So when I do the inverse sine, I get angle B equals the inverse sine of 11 over 25. So again, inverse sine 11 over 25, and we get 26.1 degrees. So on this next question, it just tells me to calculate the measure of the angle of B. And so in order to do that, we're going to again do the inverse sine. Here's angle B. So sine of B equals the opposite, which in this case is 5, over the hypotenuse, which would be 12. So the angle B equals the inverse sine. So second sine, trying to get it where it's not glaring, of 5 over 12, and I'm going to get 24.6 degrees. Now we have a word problem again, and let's read through this word problem here. It says the movable bridge shown is called a double leaf bascule bridge. It has a counterweight that continuously balances on the bridge deck or leaf throughout the entire upward swing, providing an open waterway for boat traffic. The counterweights on double leaf bridges are usually located below the bridge decks. The length of one leaf or deck is 42 feet. So that's this right here is 42 feet. The maximum height of an open leaf is 30 feet, so that's this right here. And it wants me to calculate the measure of the angle formed, so this angle right here. So the sine of the angle, which is x, is going to equal opposite. In this case, it's 30 over my hypotenuse, which is 42. So angle x, I'm going to inverse sine, if you remember. So I'm going to do second sine of 30 over 42. And my angle would be 45.6 degrees. And I've got one more problem over here, another word problem. It's about the Leaning Tower of Pisa. The Leaning Tower of Pisa is a tourist attraction in Italy. It was built on unstable land, and as a result, it really does lean. The height of the tower is approximately 55.86 meters from the ground on the low side and 56.7 meters from the ground on the high side. If the top of the tower is displaced horizontally 3.9 meters as shown. Determine the angle at which the tower leans. So it says on the high side, it's 56.7. So that would be this right here. So this right here would be 56.7 meters. So this one is a little more to it. So we actually have to kind of pay attention to what the question is asking me so I can make sure and put the right information in the right place. So it tells me that, and now I want the angle of the lean. That's going to be this angle right here. So sine of my angle x equals my opposite, which is going to be 3.9 over my my hypotenuse, which is 56.7. So what I'm going to do to get my answer is I'm going to, in my calculator, I'm going to do second sine 3.9 over 56.7. And we get 3.94 degrees. So it's approximately 3.9 degrees. That's a really small angle, which kind of makes sense with this. If this is only 3.9 meters and this length right here is 56.7, we know that this angle is going to be pretty small.